Hi, welcome to lesson 12 in the series of 8051 microcontroller programming and interfacing. For more information, you can visit us at www.jcbrolabs.org. In this lesson, we will talk about how to interface a 7-segment display to the microcontroller. So I hope all of you are quite aware about the 7-segment display, and you have seen a lot in lifts and in your toys and somewhere else. So let's see how they work and how they looks like. So 7-segment display is nothing, it is just a combination of 7 LEDs, that is light emitting diode, or we can say 8 LEDs, and which are connected, which forms a special group like this. So these are the LEDs, 7 LEDs, and this is dot. So this is complete 7-segment display. And this is how a 7-segment display is made of. So as we discussed, this is nothing but just LEDs. So these LEDs are generally combined in two different modes. Those are common cathode. If we talk about common cathode, that means all the cathodes of the LEDs are connected and they are connected to ground. So if these are all the LEDs, so all the cathodes of the LEDs are connected to ground, and if we want to turn on any LED, then we just need to put one there, and that specific LED will turn on. So if we want here, this LED will turn on. If we put one here, this LED turn on. So if we want to display any LED or any number, we just need to send one there. The other configuration is common anode configuration. So this common anode configuration is just the opposite of this common cathode. In common anode, all the anodes of this one are connected to +5 VCC, and if we want to display or if we want to turn on an LED, we just need to send 0. So this is the difference, whether your 7-segment will turn on by providing 1 or 0. That depends on the kind of connections or kind of 7-segment it is. So there are two types, common cathode and common anode. So now we learn in this video the kind of 7-segment which we have, that is a common cathode 7-segment display. That means we need to provide one to turn on any specific LED. Now these LEDs are connected in this way, and these are generally marked as A, B, C, D, E, F and G, and then this is the decimal point, and we can say it is decimal or the H. So generally the pins which comes out from this 7-segment, those are marked as like this. So they are combinations. So these pins are directly in series. So when we want to control it via the microcontroller, so we need to send a specific code to display a specific number. So now we will learn what code should be sent to display any specific number, and prior to that we need to understand like how we are connecting our connections there. So 1, 2, 3, 4 and 8. Now say we have this port 2, and the pins of the port 2 are connected to these pins of the 7-segment as follows. So pin number 1.0 is connected to A, pin number 1.2 is connected to B, pin number 1.3 C, D, E, F, G and H. So this is how connections are made from 8051 microcontroller to the 7 segment. So we have connected this port 2 of the 8051 microcontroller to this 7 segment, and in such a way that 1.0 is to connected to A, 1.1 is connected to B, 1.2 is connected to C, 1.3 is to D, 1.4 E, 1.5 F, 1.6 G, and 1.7 H, and these are the corresponding LEDs. So if we want to turn any LED 1, so we just need to corresponding bit should be 1 and then code should be sent to it. So we will start for numeric values like for 0, 1, 2, 3 and so on. So suppose if we want to display a 0, so if we want to display 0, which LED should be turned on? So let's see, this should be turned on, this should be turned on, this should be turned on, this one and this one, and G and H should be off. So if we want to display 0, so we can say, okay, let's shift it somewhere here. So we can say here is number which we want to display, and here we send the code. What code should, so our decimal number is 0, so for 0 we should send this H should be 0 and this G should be 0 and all other pins should be 1. So the corresponding code comes out to be 0x, so you can convert it 3F. So remember that this specific codes are specific to these connections only. So if you are making connections a little bit strange or different, then these codes won't work. So this code will work only when port 2 is connected to the 7 segment in this manner, that A is connected to, or 1.0 is connected to A, 1.1 is connected to B and so on. Only then this will work. If you change the connection in reverse order, then this code will change entirely. So depending on that, how your hardware connections are, you need to write your code separately. And that is why prior to writing a code, you should know how the connections are being done. So now if we want to display 1, only B and C should display, and all other LEDs should be off. So B and C should be 1 and all other should be off. So it will become 0x 0 and it will become 6. So if you want to display 2, this A, B, G, E and D should be displayed. A, B and then G and then E and D. E and D should be displayed and all others should be 0. So this code will become 0x. It is for code 2. This is 5 and this is B. So the code will be 0x5b. Now similarly you can make the entire list. Let's say for 1, 2, 3. So 3 will be A, B, G, C, D. So A, B, C, D and G. C, D and G, and all other should be 0. So it will become 0x. This is 4 and I think this is F. So if we are sending for F, it will display 3. Now let's say for any alphabetical character, suppose if we want to display A, so A will be displayed like this. So A, B, C should be turned on, A, B, C should be turned on, then F, E, F, G should be turned on, E, F, G, and other things should be 0. So it code will become 0x. This is 7 and this is also 7. So 7 and 7. So this is how you can make the entire list. So in this lesson we just skip, or we will just write this codes up to A. While doing programming, you can make the entire display or whatever characters can be displayed here. Similarly, there are also LCD. It is 7 segment. There are some other LCDs are there. LCD 7 segment kind of things are there, which have these two extra LEDs, are 4 LEDs there. So similarly, their coding will also be done like this. So we will cover up this particular 7 segment or segmented display in another lesson. So now let's write for the code for this one. So before writing code, we are revising. Our port 2 is connected to 7 segment in a fashion that P 2.0 is connected to A, P 2.1 is connected to B, and so on. And we have common cathodes. That is why we need to write one in order to make any specific LED on. So now let's write a code. Let's go to view, and let's write a code for that. Do it, project, new microvision project. So 7 segment display, project name SE, and then select ST81 microcontroller and select ATS952, and then create a file and save it like sag.c. Okay, now let's add this file to the project. And then set options for the output, like create hex file, and then OK. So now we can write it. Now let's write program hash include reg52.h, and then define a signature for a delay subroutine or delay function unsigned int. So up to now you maybe get familiar with all these things. Void main void. So let's first write void ms1 delay. So let's define two loops. J equals to 0, j is less than 1275, and then j plus plus. So these are delay subroutine, and now because we want to display these characters continuously, so let's define an infinite loop. So first we'll display 0. So simple. This 7 segment is connected to port 2 as we have discussed, so it should be 0x 3f, 0x 3f. So it will display 0, and then call delay so that we will be able to see what is being displayed there. Now let's say port 0x 06, it will display 1 there, display 1, and ms delay, and then port 2 equals to 0x 5b, it will display 2, and delay, and then display 3. For 3 is 4f was the code. 4f, it will display 3, and then now let's display A. For A, code was 77, then mass delay 200. Now we'll display only this much of characters. Now let's compile it and let's see whether there is an error or not. Okay, there is no error. Our hex file has been generated. Now prior to seeing the result on hardware, let's simulate this one on Proteus. So let's have a microcontroller first, 89C51. Here it is. Okay. Now let's have 7-segment display. Okay, these are the ICs. Let's see where we will find it. Yes, here it is. The 7-segment binary coded. Okay, binary coded decimal display. We'll use simple common cathode type. 7-segment common cathode, green color. So we hope these are marked as A0 as ABC. So just connect them. And then this connected to this one. Now let's make a hex file. Okay, let's save this diagram prior to it to a computer where all other files are. And let's run it. 0 1 2 3 A. Okay, so it's working fine. So you can also verify it by so prior to writing the your hex code on the hardware, you can verify whether your program is working or not on this simulator. So if it's working fine, so now let's move to the programming microcontroller, the setup which we have. Let's start the programmer, connect it, and let's first identify the chip. Okay, open hex file, open, and then upload. So now file is being uploaded. So in the meantime, let's see what could be the more codes for next run. Like for if you want to display numeric 4, so what could be the code? If we want to display 4, B and C should be 1, B and C should be 1, G and F should be 1, G and F. So this should be 0, this should be 0, and this should be 0, and this should be 0. So it will become 4 to 6, 0x 6, and it will also become 6. So it will become 6 6. So if we display a 6 6, then 4 will be displayed. Let's see if our programming is done. Similarly, you can write several other codes for several other combination which you want to display. So our programming is nearly done. Let's wait for finishing it. Okay, programming is done. Now let's see how the character are being displayed on the 7 segment. Hi, this is our board on which we have just programmed our hex code on the microcontroller. So this is the port 2 of the 8051 microcontroller, and this is connected to the pins of the 7 segment, and these pins are marked as A, B, C, D, E, F and decimal, and there are 4 7 segments are there. So we have connected this second 7 segment from this location, from this connector. So let's see our program. So it's working exactly the same as we have expected. So this is how we can implement, or we can display any character on a simple 7 segment. Now when there are 4 7 segments, so our program will be a little different to display a complete word on these 7 segments, and we will learn this, like how to display characters on more than one 7 segment in our upcoming video. So you have seen the output of the program, and I hope you have understood how to interface a single 7 segment display to the microcontroller. On our development board there were 3 more 7 segment display, and it is a little trick to display a complete sentence or a moving word on these 4 7 segment, and in our next lesson we will talk about it. So till then, enjoy coding, and that's it for this video. Thank you.